is a programming of the user interface in Java, native user interface. As you know, I have many doubts on using a native user interface due to different reasons. On one hand, on the other, it is worth to know how it works and what are the pitfalls and problems in that area. So let's go. Okay, so since we are talking about the graphical user interface, let's start with some history. Okay, and up till now, during the lab, you were dealing with so-called command line interface. Okay? CLI, okay, it is quite nice interface for many purposes, and I like it very much. However, in some cases, like for example, now when I'm giving a presentation, graphical presentation, graphical user interface is much nicer. Okay? And everybody has a graphical user interface on a desktop computer. And really, the graphical user interface is connected with desktop computers. This is something that is strictly interconnected. It started in early 70s, so many years ago. It was developed by Xerox PARC, and really the real system was Xerox Alto in 73 and then Xerox Star. However, okay, these systems were able to do many things as we are able to do now, okay, but it was not a commercial success. But strictly speaking, Windows and Apple Macintosh, okay, systems that came on the market later, and of course the Windows X Windows system are just were not exactly copied or based on that idea. However, the idea of communication with a computer using a graphical user interface originates from 60s. Okay, so you have here a screen of the first mouse from 60s. So in late 80s, beginning of 90s, three main systems became popular, and systems connected with desktop mostly. So we have Apple Macintosh, okay. We have X Windows system that was based on Unix, and therefore now Linux uses it. Okay, so somebody has a Linux uses X Windows systems, and we have Windows, and really Windows 3.0 became popular, and so we have three lines of operating systems with graphical user interface. Okay, so we have the idea of WIMPs. Okay, so in general, due to the problem of the word window, because Windows is used by Microsoft as the name of the system, but even it is used by X Windows system, by Unix workstations. So we name that way of communicating with computer as WIMPs. Okay, so we have Windows. Okay, so everybody knows how Windows looks like because we are using. We have icons. Okay, so that's why the second I. We have a menu. Okay, so the idea that we can select things. Okay, and we have pointers. Okay, so we can move the pointer on the screen, what I'm really doing now. Okay, so and really, of course, there are some differences among different versions of operating system, some improvements, but the idea is still the same or very similar. Okay, we have now not native interfaces, not connected with operating system like HTML is, and in a word of HTML5, it is really a WIMP system inside a web browser. Okay, because we can create windows, icons, menus, and pointers. We have now application that looks like a native application in case of web-based application. Okay, so how the system is organized, okay, more or less, okay, this is now based on a Parks example, but it could be totally different situation, but still similar, different system, but still similar solutions. So we have a windowing system, okay, that handles low-level input-output. In many cases over a network. For example, X Windows was from the first version designed to operate through the network. Okay, so we have a workstations that could be connected to the main computer, and therefore we have a possibility to work remotely. We have something which is called Window Manager, takes care of placement of appearances of windows, and a framework toolkit that is a piece of software that makes our life of programmers easier. Okay, so we have icons, widgets, window containers, events, and messages. Okay, so window and messages, events and messages are quite important because it allows us to work with the communication between a user and our application. Okay, so windowing system is manage input and output devices, so graphic cards, screens, mice, keyboards. It sends input events from input devices to applications. Okay, so we can have a mouse, a touch screen, anything what will become popular in the future that allow us to communicate with the computer. And as I mentioned before, X Windows have a possibility of remote app communication, but we have also such capabilities in case of Microsoft. So we have something that's called Microsoft Remote Desktop Connection. I was using it for many years when I was working with Windows Server. And a similar solution exists also in the area of Apple. Okay, so it deals with all elements, okay, with mouse, keyboards, with applications, okay, and communication is done by event. Okay, we'll come back to that very important aspect because this is a way how really the communication is done in case of a graphical user interface. Okay, so really regardless the system, okay, if you will learn maybe in the future a method, HTML, for example, you will have events connected with mouses. Okay, so we have really three important events connected with pointers like mouses, okay, or touchpad I have, whatever it is. It is mouse moved, okay, so the event is raised when the mouse is moved. Mouse down, the event is raised when you press a button down, and mouse up is an event is caused by releasing a button. Okay. Similarly, we have events connected with touchscreens. If somebody has a touchscreen, the touchscreen is very important in case of mobiles. Okay, so we have a move, we have a touch down, touch up. So this is connected with the behavior of some input device. In case of the keyboard, we have mostly two low-level events, primitive events, I mean key down and key up. Okay. So when we press the key and when we release a key, any key. Okay. Just look at your keyboard and you will notice that some keys has different functionalities. Okay, so you can use a Shift and A to have a capital A or a small a, whatever. Okay, but it is seen by the system as two events: pressing down the Shift and pressing down the A key. Okay, and based on that low-level events, okay, windowing system creates more complex events. Okay, so we have a click event. Okay, so clicking. So this event connects of two low-level events, mouse down and mouse up. We have double click. Okay, so two clicks within a certain time. Okay? You don't have, if your windowing system is capable of recognizing such events, and it is true, it's mostly capable of doing such things, you don't have to rely on that low-level events as it here, because that the operating system itself converts that low-level events to the upper events. It's even more complicated in case of the touchscreen, okay? Because we have gestures, for example. So several things makes a higher level event. But from point of view of programmer, this is an event, okay? So something generated by the user through the system, okay? Also, we have, for example, mouse leave, mouse enter, mouse hover. It means that a pointer was moved into a given region. Leave, it means it was moved out from the region, and hover, mouse stay in the region for a given of time. Drag and drop, okay, mouse down, mouse move, and mouse up. Okay, and such events exist almost everywhere, okay, even not mentioned by me operating system from Google, I mean Android system, okay? So regardless the system, regardless operating system, you have more or less the same style of communication. Because there are differences. There are some specific events for specific devices, okay? But generally, that events mentioned by me on that slide exist everywhere, okay? So how to deal with events? We are naming it event handling, event handlers, okay? How it's done technically. So the event, which is a kind of the information, what, when, and where happened, is of course generating from the windowing system, from the operating system, then goes to the graphical user framework, and then goes to your code. Okay, so really the thing that you will be the work for you will be to develop something which is called the event listener, event handler. The names depends on the lecture, depends on the environment you are playing, okay, of a given widget. Widget is a piece of software that is presented, gives some graphical representation. So in older Java, it was called swing components, and nowadays Java, this is JFX controls, ActiveX controls, in Microsoft things. Okay, so what is that? Okay, so keyboard and mouse events are sent to the active focus window. Okay, so when you have several windows, the operating system sends the event to the window which is on the top. But it really depends on the operating system. And within a window, a mouse event is usually routed to the widget that is displayed at the position of the mouse. So if your screen consists of several widgets, the mouse move, for example, event will be sent whenever your mouse is moving over a given widget. So strictly speaking, you have to write a piece of code that will be shown by me today that is registered, okay, as so-called event handler within the graphical user interface framework. If you will not register a method, it will be not called. Okay, so you have to prepare a piece of code and glue it with widget. Okay, without that glue, it will not work properly. Okay, so really two steps are important. You have to register a handler. Okay, and of course, inside the handler, some method, whatever, or function, some languages. So-called handler callback will be called in a situation when an event will happen. Okay. So of course, your aim is to present something on the screen and react to the user. I mean, your aim as a coder of the graphical user interface. So you have to write event handlers that follows the application logic. Okay. For example, you have a mouse click event connected with the save as button. It means that some functions that does the saving will be called. What is important, and I will repeat it once more today, event handlers should never ever perform lengthy computations, because the graphical user interface works as follows. Events are collected from the outside world and put in a event loop. And events are taken from the loop. One event is taken and sent to your handler, to a handler callback function. And when the callback function finishes, the next event is taken from the queue. So it's more or less like on the 7 Lab, but we don't have 3 clerks. Only 1 clerk is available there. So if the clerk will work for a long time, then the events will be stored in the queue. So they will be not taken from the queue, they will not resolved in the sense that proper code will be not called. It means that your application will be not responsive. So remember, if you have to do something which takes more than, I don't know, half a second, never ever do it directly in a handler callback function. What's the solution for such problem? Simple. Threads in case of Java. Okay, or asynchronous programming, but this is not the aim of our lecture. So this is a very important statement, the last one, that calculation done in the event handler should be short. Okay, in other case, your application will be not responsive. Okay, so what's the aim of your code? Or what's the aim of any graphical user interface application? Is to react on the user interface, and the React is changing the lookout of the application, doing something on the screen to inform the user that, for example, the button was pressed. So on the low level of the operating system, okay, it is done like that each widget has a magic function called paint. Okay, there are small differences among operating system. Okay, and a paint method is called, okay, when operating system wants to change something. Okay, so this is the like run in case of the thread. This is called from the outside world mostly, okay, and responsible for the lookout of the screen. Okay, so if you want to change the or to paint different things on the screen, you have to define your own paint method. Okay, so of course it is quite rare, okay, that you are painting everything from the scratch by yourself. It is possible, and sometimes it is needed. When it is needed, when you need a widget that is not existing on the market, okay? But some typical widgets like buttons, like menus exist. Okay, so you can use already developed widget that has a proper paint inside. Okay, of course, very often it is parameterized by some elements in a constructor, for example, and you are just adding such widgets to already existing widgets and making a tree. We'll come back to that idea. Okay, so we have some objects that have paints that are connected with by a tree. And so how the lookout is changed when the paint is called. Okay, there are 2 cases. One is the cause, the origin of the paint is the system. For example, when I'm doing such things like here, okay, I have pressed escape. Okay, so the okay, I will move the window, for example. Okay, or maybe this is I'm moving the window. Okay, maybe you don't see it. Okay, sorry, but try to move your window with the zoom. Okay, and you will notice that some things are repainted. Okay, so widgets must be rendered whenever they are displayed for the first time. They are resized, or you move it. Okay, and the second situation is that you want to change something, okay, because of the changes of model of data. Okay, so it is done that in the way that the graphical user interface, the framework generates the paint event. Okay, You are never ever calling paint directly. It will have no results. Okay? It is called when it is needed, so you can inject such event to the system. Okay, that calls indirectly paint. So how to do it? And most of operating systems, and therefore libraries, there is a method called repaint. Okay, so this is a nice way to request a paint event. Okay, how it works? Like all events, the event is sent to the queue, and when the time comes to it, okay, it repaints. Time is quite important. What I wanted to say here, I wanted to say here that Windows, and I mean Microsoft Windows and other type of systems are not a real-time system. Okay, so when an event happens, it goes to the queue, and when the event come to the as to be a first element is taken, and the event is realized. Okay, but if the system is doing a lot of stuff, especially when the code is not written properly, it could take several, sometimes even minutes. Okay, but in most cases, it is several or even 100 events per second per widget could be done. Of course, depends on the computer operating system, etc. So we have also something which is called invalidation events. Okay, I mean the GUI framework calls them if a given region must be repainted because of window movement or resizing, but never ever call them directly. This is done by the graphical user interface framework, and it works properly. Okay, so never do it. Okay, when it is important, just look at such example. Okay, and then you move that green window on the top of that yellow window. So to speed up the process of painting, not hold the, sorry, okay, it was a lot of events to my computer. So not all the green green window is repainted. Only a part of it is repainted to speed up the behavior of operating system. But you shouldn't do it by hand, okay? It is done properly by the operating system. So let's try to summarize, to have a general look at the WIMP programming, regardless the operating system. It is even true for HTML, nowadays HTML programming in JavaScript, okay? Because it could be seen also as a kind of the WIMP included in a in a browser, okay? No, it's not native in the sense that it's not directly called by the operating system. So in most cases, it is slightly slower. So we as programmers have to solve two problems. We need some methods that allow us to build a user interface, build widgets, windows, okay, and to deal with events. In case of building a graphical user interface, we are extensively using object-oriented programming. Okay? And I hope that after my first three lectures, we are quite familiar with that. I want to pay you attention that the development of object-oriented programming is strictly connected with WIMP systems. Okay, object-oriented languages became popular from the middle of 80s. Even they became available on the market in the middle of 60s. And the strong development of C++ was connected with the graphical user interface. And just notice that Java, C#, that languages has also its own graphical user interface. Because what you have to do, you have to create widgets. So in natural way, they are classes. You have to change its attributes. Okay, so it's parameters. Okay, so we have attributes, and you are calling some methods. Okay, so the object-oriented approach is not really required. Even me, many years ago, I was programming in Windows 3.0 in pure C. Okay, it is possible, even in assembler. Okay, but using object-oriented languages makes our life easier. Okay, so that's why WIMP widgets are strictly connected with object-oriented programming. So if you need to create a new widget, a widget is not existing, that to paint something strange, okay, maybe a ball moving up and down. I don't know why, but let's assume it's a stupid situation. You are not doing it nowadays from the scratch. You are taking the already developed widget. You are using inheritance. Okay, so you are deriving a new class, and you are just overloading a paint method. That's all. So it's just simple. Make your coding easier. Okay. What else is important? If you create a widget, I mean new object, okay, it will not be displayed. It's just creating an object. Things that are displayed are connected together. They create a tree of elements. Okay, so in case of in Java, you have to connect it with the main pane. But in HTML, this is the body element. But it does not matter how it's named. It's always a tree. Okay, called a DOM, for example, document object model in case of HTML, called pane in Swing, called stage in JavaFX. Okay, so the name is not important, but important is that you are creating an object, setting its attributes, and gluing it to already existing elements. Because if the widget is not connected with the parent, it is connected with the parent and parent to the main window, it will be never displayed. Okay. Creating objects, proper classes, which names are in English, so it's easy to be used. Okay. Okay, and then it is displayed. Okay. What does it mean displayed? It's placed somewhere on the screen. In ancient time, the placement of elements were done by hand. We call it absolute placement. Okay. Okay, it's still possible. You still are allowed to do it, but it's quite rare and quite dangerous. Okay, why is dangerous? Because it is hard to deal with, to solve all the possible problems. Well, what I mean problems? We are, for example, resizing the window. Okay, then you have to react all such situations: too large, too small, etc., etc. Okay, so much clever is to use already developed pieces of code, so-called layout panes, layout managers in case of Swing, layout panes in case of JavaFX, okay, that are responsible for automatic placement of elements. Okay, there is a family of such algorithms, and you are just selecting which one you want. Of course, always you have an absolute positioning as a solution to your problems, but this is not the easiest way to write a code that is capable to make this positioning absolute working everywhere. Okay. In case of events, we have something what is called event-driven programming, which is becoming more and more popular because it is connected with the graphical user interface, but not only. We can really see almost everything in programming as events. Okay, so we have language dedicated for such solution, and but technically speaking, it is done by so-called callbacks. Okay, so some methods, some functions are called in the future. That's why callbacks. Okay, because you are developing a piece of code that will be called when the event will happen. Okay. In words of Java, they are called handlers. Okay. Technically speaking, in C or C++ languages, or mostly in C, it was done by pointers to a function. Okay, because we need a function that will be called in the future. Of course, you know that we don't have such capabilities in Java because pointers are hidden. So the solution are interfaces. So you are making objects or making classes that implements a given interface, so-called handler, that technically speaking has a given function on mouse something. Okay, I will show it later on the next slide. Okay, and just once again, so events goes to the loop, and they are picked one by one. And event loop is single threaded. Events are taken one by one. Okay. So never ever do stuff that is long inside event handler. So how to solve it? Use threads. But threads could cause problems. The problems you were facing during the lab, the problems with synchronization. Because if two threads will try to change one widget, it will not work. So how to solve the problem of calling a thread, and then in thread you do some calculation, and the result of calculation should change the screen. In different languages, in Java and JavaFX, which will be the subject of the next slides, we have a method as it's shown here, run later on the object platform, and you put here the code that will be called within the same thread as all events. So it's like an ejection of the event, okay? So this is a way which is based on the idea of asynchronous programming, by the way, of doing things in one thread, okay? So in the other thread, you are injecting a method, or just an object that implements runnable. So you have a method run that will be called within the event loop thread. So there will be no problems with synchronization because events are analyzed in one thread, okay? It was the first time I have repeated the same, so I will try not to do it more, but remember, this is a very important aspect. So if you have to use threads in case of a long code in events, but from the thread, never ever directly change things on the screen. Do it indirectly through platform run later. Okay. In Java in Swing it was called invoke later, and C# something like that. Invoke, I think it was called invoke. Okay. So everywhere exists a solution to that problem. Okay, so let's go to. I hope that now you have at least some background. Okay, some general ideas. Maybe they will become more clear after next slides when I will show how to do it in reality, or maybe you have some experience with graphical user interface, for example, from the .NET environment. But up till now, everything was true regardless the operating system, regardless the environment. Now we'll talk about the Java FX, okay, which is the modern, okay, Java FX, I think 2010, so it's not very modern, but the up-to-date method of making a graphical user interface in Java. Okay, so how it looks like. So maybe I will show everything on the screen. So the idea is simple in case of JavaFX. So we are creating an object that extends a class, that extends application, and you have one main, the most important method called start. That is started when the Java wants to run the application, okay? And it has a object called stage, which represents the screen of your application. It's called here stage. And the idea is as follows. You are picking some widgets from the library or from widgets from your own world. Okay. So, and So you are creating them by new. You are changing their attributes, putting things together, gluing them, and finally calling the show on the stage that was passed to you as an argument. So really show presents things on the screen. But before, you have to make a tree of elements. So stage has a method called set scene, okay, and you have to connect it, your own scene, to the stage. Okay, the scene is created here. It has three arguments: the size and what you have inside. You have a container that contains more and more elements. It's like a tree. So you have a stage, scene, button in that example. The main is not really needed if the software is aware of JavaFX, which is true for most of the IDEs, modern IDEs, and it's true for the command line. It is not required, but sometimes in old IDEs, the IDE is looking for the main, okay, not for the application class. Okay, so that's why it is not needed, but sometimes useful to have it. Okay, so we put button directly on the scene, but in a real situation, we put there more than one elements together. Okay, so if you put only one element and you will not play anything with that positioning ideas that I will come back to that slightly later, the default behavior is to make the button full the entire window. Okay, it is not nice solution, but it was our first code. Okay, so quite rarely we want to do such things. Okay, so, but strictly speaking, we are making a tree. Okay, so we have a stage, scene, parent, the main pane, and some nodes put it together. Okay, so we put elements like buttons, menus, etc., on the pane inside the scene. So we have containers that are responsible for placing elements, and that panes has built-in algorithms for placing elements. Okay, and I will talk about it also today. So things are displayed and placed on the screen according to these algorithms. Okay, so idea is that the pane could contain other panes, and it makes a tree of elements. Okay, so we have a stage, and only one stage in your application, only one stage in your application. Okay, because it defines the main window. Stage has a property, so only one as a same, and you could put their nodes, and inside a node you could have other nodes, other nodes, other nodes. Most of nodes are pane, and we have different panes that are responsible for different automatic algorithms, like flow pane that flows elements, plays a grid, makes a border, a stack pane, HBox, VBox, so horizontal placing, vertical placing. Okay, and inside it we can put an user interface controls like labels, text fields, buttons, checkbox, radio buttons, text area, anything, or developed by you elements. Okay, we have a dedicated element for the images. So when you have an image, a bitmap, you can display it. And what was not possible in case of Swing, but it is possible in case of JavaFX, we have shapes. Okay, so we can put shapes inside as a node. Okay, so it's also an element of the node. So it really builds a tree of nodes. And the result you have depends on the whole tree. Some of the elements could have different automatic algorithms for placing things. Okay, so for example, the main scene will have a flow pane, but you can put there two panes. One will be grid and the other will be VBox. In VBox, you can place a pane that will be a stack pane, etc. So you have just to think, and I will talk about shortly later, what are the algorithms behind these names, and then you can achieve whatever you want as the result that will automatically place things on the screen. But let's come back to events, okay? Because I think they are the most hard part of a graphical user interface, at least when I look at my experience from the labs from previous years. Unfortunately, in your case, I was not able to work with the lab with graphical user interface due to Fridays being forward to Tuesdays at our university. Okay, so, but if you will have some time, it is worth to do a simple code by you concerning the Java effects. Okay, so event-driven program. Okay, so for example, we want to respond to the button that was shown on our first example that will do something. How to do it? So the button will be an event source. Okay, so will be the source of the event. So we'll have to connect the destination of the event, your code, to that source. Okay. So strictly speaking, you have to create an object that is capable of handling the action. Very high level action, because click is really sophisticated event, because it could be done by mouse, by touch, by touching, using a touch interface if you have such capabilities on your computer. But you can even press a button like enter, and automatically it means that you clicked the button. Okay, so this is a really high level event, by the way, the clicking. Okay, and such objects are called event handlers. Okay? So you have to develop an event handler. That's your responsibility. Okay, so you have a button, event coming from the Windows system, and the handler that is called when event will occur inside your button. So your button has to be pressed. So the pointer has to be placed on the button. So the event is raised, and if you register before the handler to the button, the handler is called. The handler has at least one argument. This is the event. And the event describes what was happening. Okay, it has different properties, like even the time when event happened. Okay, it's an event object. So we have the event source object, the widget. We have the event object that represents the event, and we have the event handler object that represents the functionality, what would happen when event will be raised. Okay, everything is an object because we are within an object-oriented language. Okay, not just only an object can be a handler for an action event. Okay, so how to do it? Technically speaking, it is not simple, but due to some modification in Java, like lambda expression, it became easier than it was in ancient time. Okay, but strictly speaking, idea is like presented here. You have to implement an interface like that. Event handler parameterized by the type of event. Okay, so you have to build an event handler for a given type of event, which defines the common behavior for all action handlers. Okay, when you will do it, you have to register it. Okay, so it has to be registered. Okay, now the function is called send on action. I was also programming in Swing. It was called differently, but still the same idea. Some technical differences exist. Okay, it's slightly different in case of HTML. Okay, we don't have handlers, we don't have interfaces because then we have a JavaScript code. But the idea is the same. We are creating a function, so the event handler, and we are registering it like on click attribute in HTML. Okay, so all graphical user interfaces are very similar. Okay, they are technical differences, but the idea is the same. Okay, so here you have to connect the code with the source. So the source is a widget, like button, for example, and the method is called setOnAction. So as it was in case of widgets, the widget will be displayed on the screen, not when you are creating it, not when you are making its properties, only when it is connected with the main stage. Here, of course, it could be done indirectly through parents. And here is the same. You have to create an object, but it's not enough. You have to glue the handler, to connect the handler with the source of events, I mean with the widget. So remember, always two steps, creating and connecting. Okay. When look deeply in event handler interface, it has only one method, okay, handle action event for processing the event. So since you are creating an object that implements the interface, okay, you must override this method to respond to the event. It is a Java trick to solve the problem of pointers, okay? It's working. Okay, so let's look in a slightly more difficult code, okay? So let's start from the end. So we have show, like it was previously. We have a sign, as it was previously, the title. But here we are making a sign, okay? And inside the sign we have a pane. Here the pane, the thing, I will come back to it, that's responsible for placing things together. Now have a horizontal box, okay? And we are informing some parameters to the pane. I will come back to it later. But we are creating a button or two buttons, okay? And what is important, we are making a handler and connecting the button with the handler, okay? So setOnAction, an argument is a handler, okay? So let's go to the handler, which is a stupid didactic handler, okay? So it is just implementation of the handle method that prints something on the screen, okay button was clicked. And the same stuff we do with the cancel button, okay? So we are adding a handler, the separate handler, the other handler. That's why we know it's one of the solutions that allow us to know what was the origin, where we are. We have different handlers for different buttons. We could have the same handler for the different buttons, and we need some tricks to know which button was called. So this is a slightly easier solution. Okay, so we are making other classes inside the main public class, so they are not public because the name of them are different than the name of the file. So we are making the, let me summarize the screen. We are making the user interface, okay? We are making handlers and registering handlers to given widgets, okay? So if OK will be clicked, then that object will be called. If cancel will be clicked, then that object will be called. Why? That line defines the click for button cancel, okay? setOnAction. So In the style of programming we are now dealing with, that one connected with events. Events define or drive the program execution, because it's like a huge switch. Okay, yeah, preparing a functions, a set of functions, and they will be called whenever something will happen. Okay, that events will drive the code. It could be seen like a signal, like a message that something has happened. Press the button, move something, uh, press the key, etc., etc. Most of the events, but not all, are triggered by users. Okay, but some events could be generated by internal program activities. Then we have a time events, okay, caused by some timers. So I know it's the best analogy, but it's a kind of an analogy. We could see the events like exceptions. Okay, so we have objects that corresponds to something happening. Okay, so in exceptions, we were creating objects and throwing them, right? And somebody was catching them. Okay, it could be the events could be seen slightly similar. Okay, they are used for different purposes because they are thrown by operating system, I mean events, by other programs, and you are catching them, of course, in a slightly different way, but we are using some data here, events, there, exceptions, to transmit the information, okay? So an event object is created and fired when something happens in our user interface code, okay? So that object is sent to the register handler from the object that generated the event, the source. So source, event, and event handler. Okay, so let me once again show the screen, which I hope explains everything. Okay, so we have a source, event that represents the data generated by the user behavior, and handler that is called when the event is raised and has that event as an argument. How to handle events in more easier way in the sense of coding than just by creating classes. Okay, so let's repeat how it was done on the previous slide. So we are making a button, we are creating an object that will receive events in the future, and then glue things together. These three steps are always true. We have something like anonymous inner classes. I was talking about it on one of my first or the second lecture, but I don't know if you remember. So it is possible to create a class, okay, within a object. So it's called the inner class. What is a nice feature of such solution is that if you are inside an object, you have all attributes of the class you are in. Okay, so this is quite useful to pass some arguments because very often the handler has to do something with objects created previously. Okay, so okay, we can use constructors to pass arguments, but using inner classes makes the coding easier. Okay, and this is typical for Java. Okay, so you are overriding and handling things. Okay, so let's look at a more sophisticated example, but quite similar to the previous one. Okay, And what we are doing, we have four buttons. Okay, we are adding them, and we glue some functions with each button. Okay, so and this is a way how the anonymous inner classes could be used here, and this is quite typical for Java. Okay, so but it is okay like that. But when you have anonymous inner classes, you don't have to use class something. Okay, they are called anonymous because you are not giving names here. So the code is shorter, and the code is easier to understand because you have the code, the interface close to set on action, so close to the other code. Okay, so you could all four elements are the same. What is nice that here you have an access to that objects created here because we are inside the method, which is very often quite useful. And the next step are lambda expressions that makes a coding even shorter. Lambda expressions gives nothing new in general, but allows us to shorten the code. And they are really useful in case of anonymous inner classes. Okay, so they could be considered as a abbreviated syntax. It was proposed to Java for the version 8, but similar solutions exist in other languages too. Okay, so compiler treats lambda expressions like an object created from anonymous inner class. Okay, I will come back to the previous slide. You notice that the code is quite long. Really, what is interested from us is that do something, and all elements override public handle and that stuff is always the same. So the idea was to make the coding shorter. Okay, you know that Java is very exhaustive coding. You need to write a lot of characters to achieve the solution. That's why lambda expression are quite nice, especially in Java. Okay, so the code on the left and the code on the right is the same. Even it does not look the same, but it has the same result. Okay, just you are putting more stuff on compiler. Okay, since compiler knows that set on action expects event handler, so it places it here. Okay, so whatever will start here and will be stored here will have the same result. So that short notation maybe does not explain how it works. On the left, that left part explains how it works. But of course, that shorter notation is easier. You will agree with me than the longer expression. Okay, that's why not only because of that example, but similar situation, lambda expression became quite popular nowadays, and we have such solution in different languages. Okay? So this is not a new or different solution. It's more or less the same solution, but with the abbreviated syntax, okay, with lambda expressions. So we are using these two characters to define the lambda expression. So this is the argument passed here, and this is the code run here. This is the same code here. Okay, so these things are the same. Okay, so because the compiler knows that the parameter of the set on action is event handler or action event, okay, and since that a particular interface has only one abstract method, so he knows that the code between the braces must be statement for that method. That's why it is possible. It could be used only in such case when, but similar cases is the run method, for example, in case of the runnable interface. So now we have the same code as previously, but much. Okay, and now the same code using lambda expressions. Okay, you can notice that it's much shorter, but it's the same code. Okay, has exactly the same results, and it really will be compiled to the same class files. Okay, so you can notice how the languages are improved to make our life easier. So the first solution, which is the worst, I mean the larger number of coding, is to define an external class. Okay. The second solution is anonymous inner classes. Okay, they are slightly different, but now we have less coding than previously. And the third step is using lambda expressions. So of course, I recommend you such code. You can notice that we have four different styles of using lambda expressions. Okay, they have the same results. This is the most sophisticated. So argument, the type of argument, the result. Now we don't have a type of argument because it is defined, because we have only one set on action method. If we have two set on action methods, which one should be selected? Okay, the type defines. Okay, and since we have only one line, we don't need brackets. This is the shortest, because it could be done only when we have only one line of the code. Mouse events. Mouse events are connected with mouses, but when a file, whenever the mouse is up, down, moved, whatever. Okay, so that's why that events have names connected with the functionality. So we have an event called mouse pressed when the button goes down. We have the event called mouse released when button comes back up. Okay, down, up, mouse pressed, mouse released. When it's clicked, mouse clicked. You can react to mouse pressed or mouse clicked. It's up to you, or even to both, but sometimes it's stupid. Okay, mouse entered when you move a mouse and the mouse on the pointer. Okay, the pointer is over a given element. So mouse entered, mouse exited. Okay, otherwise, and mouse moved. Okay, be careful with mouse move, because mouse move is raised very often. When you are moving a mouse, a pointer by mouse over a given object, each several milliseconds, the mouse moved will be called. So, okay, sometimes such event handlers are needed for example, when you want to deal with drawing. Okay, you want to draw something on the screen. So you catch that event, an argument, the event gives you the information where the pointer is placed. So you are placing a dot in that place on your window. And now you have a paint. Okay, or the paint, the Microsoft Paint, okay, system. I'm joking. And connected with events, we have a mouse drag. Okay, so when we move a mouse with button held down. Okay, so how to handle such low-level events? In similar way as previously, the type of the event defines the type, I mean that the class here defines the type of the event. Okay. So for example, you want to react on mouse drag. Okay. So the result will be that you will move the thing on the screen. Okay. How it's done? Very simply. I'm creating a user interface. Okay. So creating a pane, placing a text inside, and connect that widget, just text, with the event. I want to move that element on the screen using a mouse. So that's why I'm using set on mouse drag. Okay. So the name of events, the functions are connected with the type of the event. Okay. So set on mouse pressed if you want to react on pressing. Set on mouse exited if you want to react on leaving the element. Okay. So it's simple. The name after set on is the type of the event. But what I'm doing here inside, I got the event, and the event is a type, and when you have some time, it is worth to analyze all its attribute. But it has also an attribute called, or method called getX, getY. It returns the position of the mouse within a given pane. Okay, so what I'm doing, I'm placing a text on that position. So I'm changing the position of the text. That's all. So using a mouse, I'm able to move the text on the screen. Okay, the button has to be, the mouse button has to be pressed because I'm reacting on the set on mouse drag. But it shows how it's done and why anonymous inner classes or the representation. What I mean, the representation, I mean the lambda expression helps of coding because this is anonymous inner class. So I have an access to all local arguments defined here. So now coding is easy because I want to do something that change the text attributes, but I have an access to the text because if it will be a separate class outside that application, I will have to pass the text as an argument and the coding will be longer. Okay, for sophisticated things, large reactions, it is nice to have it as a separate function, to have it as a separate class. But for such small things, the lambda expression are totally perfect. Okay, makes the code. Anonymous inner classes and the representation, I mean lambda expression. Okay, the other stuff is connected with placing things on the screen. Okay, so we have been talking about. Okay, so we have mouse events because similar way we can do with any other mouse events. What about key events? It's quite similar. Okay, it's not the scanner, of course, now because it's connected with the widget. Okay, so we can get information when the key down, key pressed, key released, or up and down, so key type. Okay, we can also check the if other things, I mean other keys, functional keys especially, are down. Okay, so we have functions inside the event. Okay, that something was shifted, altered. So is alt down, is shift down, is control down, or because it's a custom that that functional keys has influence on the functionality of applications. What's maybe funny that key events are not displaying anything. Okay, of course, you can display it, but it's not like a scanner in a CLI that automatically displays something on the screen. Now it's your responsibility. Okay. Of course, you can do it. You can read the code because the key and the character is not the same. Okay, they are connected, of course, but the dollar is on my keyboard with 4, but I have to press Shift 4 to have the dollar. Okay, so one way is to react on Shift 4. On the other way is to just use the get code that generates the character. Of course, be careful that some keys on your keyboard are not generating any characters. Okay, just pressing Control does not give you any result from the get code, or sometimes you have codes that are not printable. Okay, so like up, down, at that kind of codes. Okay, so let's see how we can play with keyboards and do simple things. So moving the text, the same text as it was shown before, on the screen using your keyboard. Okay, so more or less the same user interface. So we have the same, we have the pane, we have the text, but now we have a different event handler. What I mean by that I have a set on key pressed. So this is the name of the function, and now registering the event. So the event has a method getCode that allows you to read what code was done. And if the code is down, okay, or if the code is up, left, right, I'm doing different things. So I'm changing the position of that text up, left, right, down. In our case, so that's why I'm using default, I'm checking if that character is character, okay? So I'm getting text and changing it on the screen. So I could change the letter to the other one, okay? And that's all. Simple, still the same style, set on something, but now you are capable of doing things with keys. And finally, I would like to come back to the problem of presenting things on the screen. So a few words on layout panes. Okay, so panes have a built-in algorithm that allows you to place things in a certain way. Okay, so we have a pane, just a blank canvas. Okay, and on such pane you have to place things directly, but you can use some already developed algorithms that are responsible for automatic placement of things, okay, according to some method. So stack pane places nodes on the top of each other in the center of the pane. So like a stack, one on the other. Flow pane, one of the most used and very, let's say, expectable results you have here. So you are placing things row by row, horizontally, or and then vertical, column by column. Okay, so it's like reading order. The first widget, the second widget, the third widget. So of course, depending on the size of widgets, depending on the number of widgets, you could have a diff, and the size of the of the window, you will have different results, but it's like a flow of elements, one by one. When it finishes, next line, next line. Grid pane, you have a like Excel, okay? So you have a table of elements, like table in HTML, and you have a 2D grid of cells, and you place nodes there, one by one. Okay, so they have the same size. Border pane, I will show it slightly later on the screen, which divides into 5 elements. H box, horizontal rows, V box, vertical columns. Okay, so depending, and just remember what I said before, an element of the flow pane could be a 2 stack panes and 1 grid pane. Okay, so the result is a mixing things together. Okay, so flow pane can be set up in reading order, okay, or top button, so reading for Chinese, okay, or Japanese, okay, from up down. But by default, it's horizontal. and you can define the gap between nodes in pixels. Already I was showing you button on such pane. So flow pane is presented here. Okay, so I'm making a flow pane. I could change the padding. Okay, send gaps in horizontal and vertical elements. Of course, these values has a default values. Okay, so you don't have to do it. You can place nodes in the pane and show it. And this is the pane. Where are you putting things? You are adding children elements, and they will be shown according to that algorithm. So flow, and you define gaps and insets. Okay, maybe this one is quite important picture. Okay, so you define a pane, edge gap, horizontal gap, virtual gap. Okay, and you have some margins up, right, left. So insets. This is the side of the top right, bottom left. Okay, so these elements define these margins. Okay, so of course the result depends on the size of everything and the size of each element, but you are now defining things that give you some results. Maybe it's not because time is passing by, so I would like to focus on things that are, I think, hard or important. Flow pane. Okay, so this is an example of the result of the flow pane. When I will move right, the elements are moved according to the flow. When I will enlarge the window, the position of elements could change. It's called the reflow. Okay, because it's nice to wrap application automatically to resize, not to do things by hand. Grid pane. Okay, so it will give you such results. Okay, so it allows you to put elements in the grid. So for example, such windows are typical use a grid because you have a 2D, one line, second line, and here you have columns. So it's nice to have elements on the grid pane. Border pane makes the screen like that, elements in the center. So very often it is used for the main window. We have a menu put in the top, such some elements on the bottom, center, maybe some elements on the left, right. Just look. Okay, this is the window from the PowerPoint, but just look. It's like that. We have top. Okay, we have left. We have bottom, and we have center. So very often it is used for doing stuff on the screen. Okay, it represents a typical user interface. So coming to some conclusions, let me allow once again show, I think, the most important slide. Okay. So during building our modern graphical user interface, the idea is based on object-oriented programming and event-driven programming. So for creating elements putting elements on the screen, you have to create a widget. So you have to get some already developed classes like label, text, button, whatever, changes attributes. Okay. Sometimes you are creating new widgets. I was not showing it, but it's only one lecture on that subject. Remember to glue your widget with upper pane, upper widget to have it glued to the main stage. Without it will be not shown. And use layout panes, that algorithm, like grid pane, whatever else, to put things together. Remember that within a given, can use for the whole screen a given pane, and for example, on the left, you can use other pane. Okay, so mixing panes together, sometimes different panes, you can achieve the results you want to have or follow some other designs. Okay, so layout panes are recommended. Try not to use absolute positioning. To connect your application with the user, you have to use events. So the event-driven programming. So you have to develop handlers, so objects that are implementing a given type of interfaces. Usually the name is like mouse move, mouse over, that defines the type of the event. They are interfaces in Java, but nice solution are Lambda expressions nowadays. And remember that you have to connect your handler with a widget, okay? Because events goes to a given widget, okay? So when I'm moving a mouse on that yellow widget, large number of events I my mouse move could be generated, but if you don't want to generate them, you don't have to register them. You don't have, if you don't want to not generate them, you don't want to respond to them, you don't have to register the event. And within event handler, especially when it's coded like a Lambda expression or anonymous inner classes, you have an access to other pieces of code, okay? So to other objects like that button, and then you can change that button. I mean, then some attributes, color, whatever, or add new button. So you are changing the user interface. We are reacting to the event and goes further. So on one hand, creating a graphical user interface is easy. It's following these common ideas. Of course, there are a lot of details, and sometimes you will need to develop your own widget that to do things that are not available. But a lot of typical stuff like many text fields are already developed. So just pick them from the library and use them. And I think it is everything for today. I mean, for the lecture. So I would like to thank you for your patience, for listening to me. And next Tuesday, Darius will come. Okay, and now it will be his responsibility for the next lectures. Of course, we will meet with you, some of you, today on the lab. Okay, and what is important, maybe especially during the first group, I'm always very busy because there are a lot of you, so I could forget. But remember that my aim for today is not only to give you a mark for the lab 7, it's to give you or propose you a mark for the whole Java part, which will be a half of your final mark for the lab. Okay, because today, Tuesday, is also the last Tuesday with me. Of course, if somebody will be unhappy or there will be some problems, I mean, not enough high mark, we could try to solve the problem. And always I will try to, I will try to answer your email. It's still, because it's not the end of the semester. So do not be nervous if you have not enough time to finish it for today. Of course, I'm taking into consideration my rules. The rules is simple. If you are delayed, your mark is lower. But it's not the end of the world if you have no time to finish it for today. So thank you very much for your attention, and see you with some of you on the lab. Bye-bye.
Bye-bye.